Morning. Welcome everybody to this first session of the day. I'm Guy van Leemput. I'm the technical host and monitor of today. So I'm going to be introducing the first speaker of today, which is Puppini. So Francesco will introduce himself, but he's had a long career in data modeling and business intelligence. So I'm going to give the floor to you, Francesco.
Thank you, and hi everybody. Good morning for the ones that are in Europe, and probably good evening for someone who is in Australia. So I'm Francesco Puppini, and today I'm presenting to you building the unified star schema. Well, I guess I can start. So quickly about myself, I am a consultant in business intelligence since 2001. I worked a lot on business objects and SQL initially, and then I was curious to understand more about the data source. So I went to work for Teradata, where I was observing how a data warehouse is built, and that's how I got into data warehousing. And then I moved back to the front end, working a lot with Click, like, I don't know, 10 years. I'm an expert of Click, and working with Tableau, which is actually the demo that I will do today is based on Tableau. And now I'm actually more interested into moving into languages like Python and R. So the topic that today I want to cover is the business intelligence, which is the art of delivering information to the businesses. And these are dashboards that we can see from, I downloaded them from internet. This is a typical dashboard that we all know. And the question is, how do we achieve this? And I'm well aware that I'm presenting at a conference where big data experts are participating. Nevertheless, I'm sharing things to you that you may have probably not found in literature. The things I'm showing to you today, I never found in a single book. So I'm actually happy if someone gets in contact with me later and tells me, yeah, the thing that you said, I found it in the book of whatever, someone in the past, because I never found these things. So here is an example of AdventureWorks from Microsoft. It's a sample database that many of you may know. And it's a OLTP database. So it's a database that is a fake one. It's a dummy data, but it's an imaginary database of a transactional system. It's not prepared for being a data warehouse or like Star Schema, like Kimball. It's just the OLTP structure. And I want to observe that in this database, joins are given. So in this schema, we can see exactly now it's zoomed out. But of course, if you zoom in, you can see that sale order details and product are joined by particular order detail column, order detail product, for example. So you see in the documentation how to join tables. So it should be easy, but instead, the business intelligence, nevertheless, is slow, expensive, and very often it produces incorrect numbers, not matching the data source. So for me, an incorrect number is a number that is different from what is written in the data source. I don't judge if the data source is wrong. All I'm saying is because it's given, we should be able to read that number and show it to the screen. But what is happening is that that number sometimes is appearing double or triple. And I want to explain why and how to solve this problem. So why is this happening? I have chosen to present today a very simple database based on Excel that I've prepared for the sake of this presentation. It's actually database that I'm using quite often because my philosophy is that we don't need huge amounts of data to show principles. So principles, you see them much better when you have 10 rows or 5 rows. And this is the case of the database that I'm showing to you today. As you can notice, it's a super classic. There is a sales table. It's more similar to an order detail table, so a table which has information about the client and the product. So, and this sales are done by a client, which is in a country, and we are selling a product with the product ID, and this same product was previously purchased from a supplier. So it's an imaginary company that is simply not manufacturing, but is simply buying and reselling a product. So it could be like a shop online, for example. All these tables, sales and purchases, they have a date, so they connect to a calendar. And when a client is buying something, then there is a shipment. And sales and shipments are in a one-to-many relationship, meaning that if I order 4 units of something and only 3 are available in stock, could be that the 3 units are sent immediately and the fourth one is sent later. So that's why one row of sales may match with multiple rows of shipments, one too many. As you see, we have the classic notation of crow's feet. So it's all the joints, as you see, are many to one in the direction that has the many on the left and the one on the right. This will be very important later, I will show you, because this is what I have called in the book that I've written, which I will show you in a minute. I called it oriented data model. Also, this oriented data model is a thing that I've never seen anywhere. I'm quite sure that someone has talked about it, but I've never seen it anywhere. And it's very, very useful. For example, the one that you see here is not oriented. You see the arrows are going a bit left, a bit right, a bit down, and a bit up. So this is oriented. If these are arrows, so this is the arrow, the direction of the arrow is the one on the primary key. These are all arrows that are oriented from left to right. Foreign key on the left, primary key on the right. And when a join is many to many, we simply do not create any arrow. This is my oriented data model. So I've created an example where we have, let's focus now on these two tables, sales and shipments. And I'm showing that in the sales table, I have 5 rows, you see, and I imagine that there are 2 clients, Bill and Francesco, and on a date, 1st of January, Bill is ordering the product number 1, he's paying with PayPal, and he wants a quantity, and he pays 100 euros. And then the second day, he orders another one, and then Francesco orders another one, and so on. And then on the 4th of January, Francesco orders the product number 1. He wants 4 units, which he pays immediately with card with 400 euros. But what is happening is that these units are not all available in stock. So what is happening is that the store is sending to Francesco on the 4th of January, immediately, you see on the same date, 3 units. And then they send 1 unit later on the 3rd of February, let's say, just for having a second month in our reporting. As you see, then the order is completely fulfilled for 3 plus 1, and also when it comes to amount, which is usually the figure that is interesting in the reports, if you look at the numbers, you see that you have for 8 400 600, so it's 900 the total here, and also the sum of this number 4 5 7 8 9. As you see, both tables have a total of 900. This is important to remember because I will ask you, there is a question in the poll that you can already start to answer now, but I will show it to you in a minute, because I have a doubt. The doubt is what happens if we join these two tables together. And as simple as it is, this is the central problem. If you've worked in a company in the past and the numbers were not matching, there was some mismatch in the reports when compared with the data. Typically, the problem is this one. And guess what? This one does not have a name in literature. I call it a fan trap, but I'm not aware of one single book in literature that calls it fan trap. Fan trap is a name that I learned from business objects, SAP business object, but when they define it, they use 3 tables, and that's misleading. So there is not one definition that I found in the web from the books of literature or from the literature of software that says with 2 tables you can have a problem of duplication of numbers. So again, if you find it, please let me know, because I've been searching for a lot of time, and it's always 3 tables. It's never 2 tables. These are 2 tables, and look what is happening. What happens if we join these 2 tables together? So imagine that you put this table into Tableau. You load them into Tableau, and we will do it right now. So we have sales ID 1, 2, 3, 4, 5, and as you see, the sales. Let's look at the tables. So the row of sales number 5 has 2 rows of shipment. You see, that's the foreign key that points to the primary key. Sales number 5 is 3 plus 1. So What is happening? We have here 300 and 100, and it's okay because the total of this column is 900. But, and that's a question that you can answer in the poll, what is the result if you look at the total of the sales amount column? Because if you now do the sum, 4 plus 4 is 8, 1,000, 1, 2, 3. So the total here shows to be 1,300. So what will be the total that Tableau will display? I'm actually trying to see if I can see the results of the poll, because that's I guess somewhere else. So
Otherwise, I can help you, Francesco, with that. I see 1300 and 900 are the two results.
yeah,
900 has 7 votes, 1300 has 10 votes right now.
okay. So that's fine. Okay, let's continue. Now I'm doing the live demo, and so more people will answer, I suppose. So I'm opening Tableau, I connect to Excel, and I go to the data source. This data source has the tables that you have seen in the model. So we have sales. I can double click on this, and the shipments. I double click on this, and in Tableau you have to create the join correctly. It's actually not a join; it's called the relationship. It's a different thing, and this is also in what in Click is called in-memory association. It is not a join. People think that it's a join, but instead it is not a join. It's totally the opposite because it produces different numbers. So I go to put sales ID here, and I go to put sales shipment sales ID here. Okay, so now I go to the front end and I take the sales ID and the shipment ID. As you can see, we have sales 5, shipment 5 and 6. And then I put the sales amount. You see that the number 400 is repeated, and it should not be repeated because the number 400 in the data source appears only one. And then the shipment amount. So when I'm putting the total here, of course, okay, let's keep the order as the slide this way. So for shipment amount, you clearly have 900. But for sales amount, is Tableau going to show the sum of these numbers, which is 1300, or is it going to show the number that actually is correct? And I can go to the data model and show it to you also on Excel. So if I go to shipments and I do this, the total is 900. And if I go to sales and I do this, the total is 900. Okay, so what is the poll saying?
Still the same right now. So 10 votes for 10 votes for 1300, 7 votes for 900.
Okay, so I'm going to show it. And actually, the number that appears is 900. So the sales amount is showing 900. And this is the effect of the in-memory association, or should we call it relationship, as Tableau calls it. This way of connecting tables was introduced in February 2020. Before that, for I would say 10 years, Tableau was doing a thing completely different, and I can show it to you now. So I open a second instance of Tableau, and this time I will show how Tableau was behaving until January last year. Okay, so I open the same data source, and I take the same sales table, but this time, instead of bringing shipments here with this line, which, by the way, if you think about it, was not even asking me about left join, right join. It's just a line, orange spaghetti, let's call it, okay? Instead of doing that, I double click inside sales and I put shipments here. So I double click. So now it's a totally different thing. This is how Tableau was for 10 years. And this is called join. This is a join. A join is taking two tables and is merging them into one table. This is what a join is. This is what we have in the SQL language. The thing that you have seen earlier is much different because it's taking two tables and the result of them is two tables. So the tables are not merged. They are only merged later in the visualization layer. But if you click on the two tables, now let me show you, you have 5 rows of sales and you have 6 rows of shipments. You recognize it. So 5 and 6. They are both available at their native granularity. If you look at the Tableau, how it was in the past, the result of this thing is that we have nothing at all, but we should have, let me see, it should probably refresh or something. Oh, no, sorry, because by default, it's joining probably by the wrong field. So it's joining by notes, which is of course bad. So you put sales ID here and you put the shipment sales ID here, and now they become 6 rows. So these are 6 rows, and there's only one table which contains the columns of sales and the columns of shipments. All these columns, you see, these are from shipments, and these are from sales. So two tables become one. That is a join. Two tables remain two tables. That is a in-memory association. And guess what? Now that we have done the join, which is what we all do with the SQL language, what is happening? It's happening that if I put the sales ID again and the shipment ID again, and I put the sales amount, I put the sales amount and the shipment amount, and I keep the order as I did last time, and I make the names a bit more clear. And now I put the totals. This will be clearly 900, but now this, and it's same software Tableau, and it's using the same data source, but this time it's showing 1300. So with the join, you denormalize two tables into one, and Tableau is executing the sum of these two numbers, 400, although the number 400 only appears once in the table of the sales. So Tableau was for 10 years delivering a wrong number. And now Tableau has introduced this new thing called in-memory association, or they call it a relationship, which is a bad name because it also has a different meaning. But now they deliver the correct number. I'm showing this thing to you because I don't know anyone. It's very rare that I meet someone who says, "Oh yeah, now with their new relationship, numbers are different." There must be someone who knows Tableau well, but here it's not about Tableau. Here it's about data modeling. With this demo, I'm showing to you that the join is behaving like the old Tableau, the one that was delivering wrong numbers. So when we are populating a data warehouse, we cannot put these two tables into one because we are duplicating the numbers. So when do we always duplicate the numbers? No, when you have sales and products, you can do that. You can denormalize sales and products and clients. You can, because this is a schema where the numbers are in the fact table and there are only dimensions. And instead, when you have sales and shipments, these are two fact tables which have one the foreign key of the other. Pardon. So it means that according to the traditional data modeling, if you just do things like that, you join two tables as the documentation is telling you, because it's telling you shipments as the foreign key to sales, you are producing numbers that are duplicated. So let's understand how this was happening and how we can prevent it. Okay, so I go very quickly through the slides. This is a sales table and it contains a number. It contains a measure. So the sales amount is a measure, what Kimball calls a fact. And also this contains a number. And they are in a one-to-many relationship. So imagine that every time that a table contains measures and is joined to a table that explodes that row in multiple rows, logically, it's obvious that the number will be repeated. So this, I call it fun trap, but the definition of fun trap with two tables usually does not exist in literature. It has three, and it does not even mention the definition that you will find on the web, the one of fan out from Looker. It does not even mention the presence of a measure. And actually, the presence of a measure is the heart of the problem. When you have a measure, that's where you need to be sure that you're not joining that table in a one-to-many relationship. So, as a recapitulation, that was the question that I was asking, okay? And here you see the result. If you load it by relationship, also known as in-memory association, you have the correct number despite the repetition. So by default, the number is correct. While instead, if you do the join, you have the wrong number. So by default, it's wrong. It's clearly wrong. Then, of course, there are tricks to do to bring that number to 900. So Tableau has a syntax called level of detail, and you can make the average on the primary key and stuff like that. And you, at some point, you reach that number, but not if you're a manager, not if you're a normal person. This can only be done by a data expert who knows in advance that a combination of two tables will be generating a fan trap, according to what I call a fan trap. And this is not happening in companies because fan trap is not in literature. The data experts are not aware. The most attentive, yes, but they have found it on their own. So they have not read it on a book. So typically, if you have a team remote and they execute what they have studied on the books, they will not be able to detect and prevent a fan trap. And they will display 1300, and 1300 is a number that is wrong because what is written on the source is different. Okay, let me check the time, 9:23. So there is a key concept. Please watch me into my eyes. It's very important. A key concept that I wrote in my book. Some particular combinations of tables cannot be joined together. So it's wrong to decide to denormalize. I'm not saying all the combinations, some particular, and they are fan trap, chasm trap, many to many, and then there is something to say about the loops and about the non-conform granularities. So these are 5 chapters of the book that I've written, and each chapter is giving a definition of the problem and one or more recipes for the solution of the problem. So the conclusion, the join versus in-memory. With the memory association, the displayed numbers are always correct. With the join, instead, they may become incorrect. To fix this problem, we are forced to do aggregations. So basically, we need to aggregate. If we have two tables like sales and shipments, we need to shrink shipments at the same identical granularity as sales. So this way, they line up perfectly, or they don't because there are holes, but this is adjusted by the full outer join. And this way, you will not break the numbers. But with aggregations, we need to remove some detail. So we lose information because if we aggregate shipments to the level of sales, for example, we have to give away the information of the shipment date because you have two different dates for the same row of sales. So that information has to go away. So what is the result of that? Nothing bad, because that information is still available in the original tables. So it's not in your query, but it's in the original tables. But wait a minute. If you're populating a data warehouse and you're creating a denormalized table, and then you're saying this is the table that the users needs to use for reports, then this table will be useful when you want to compare the totals of sales and shipments. But if there will be a new business requirement that is asking to show, for example, the latency, like how much time a client was waiting to receive what they ordered, so that is measured in days. It's the difference between two dates, and this type of report would not be possible with the join, with the query that was done. So you need to create a new query, and it happens that for each business requirement you need to create a new query. This is how the world is today. For each business requirement, there is a sort of a new project that starts from the collection of the requirements and so on. And it's working, except it's very expensive. It is very expensive, and it should not be like that. So association only exists in a handful of BI tools. I am aware of 3: Click, Tableau, and Power BI. And then there's a 4th tool called Good Data, not very known. And these are the only 4 tools that I'm aware about, that when you join these two tables, they show it's not a join, and they show the number 400 repeated, but they show the total correct. Okay. Unfortunately, this behavior does not exist in the SQL language. It doesn't exist. And it doesn't exist neither in Python and in R. The operations that you do when you create a new data frame, well, if in the new data frame you're repeating 400 and 400, from that moment, the machine learning algorithm that you will build and the model that you will create of prediction can probably do predictions, but it's showing a past that is not matching the real past because it's showing 2 times the number 400. So you cannot make a join in a machine learning algorithm, because if you do that in the presence of a fun trap, you are training a data model with numbers that are not matching the truth. You understand? It's a serious thing. Okay, so most other technologies dealing with tables do not behave like Click, Tableau, and Power BI and good data. So, but then, how do we obtain the correct numbers in SQL and Python and R and in all the other existing technologies that deal with tables without losing detail? And especially, how can we do machine learning without giving incorrect numbers to train the model? So I like to show this image of the operator to again stress once more that it's fine today, it's working somehow to some extent. If people test, also the process of testing is very strange if you think about it. They give you a number and then they say, okay, give me the same number that I gave to you. And then they have to test that we actually gave them the same number. What world is this? I mean, it's given. So data is given. It's not like you are predicting the future. They're asking to show the past, and we have to do the operations that we learned at primary school. How can we possibly go wrong with that? So we are doing reports. So the business is asking for a report, and they need to ask an operator, so a data expert who is doing the correct SQL, not creating duplicates, and then delivering the result. And then there is a test to make sure that everything is matching. But the question is it possible in the year 2021 to make maybe the end users independent from the operator? So this is what the unified star schema is about. I wanted to introduce something that gives data to the business users, eliminating those pitfalls that break the numbers. And now I've done a demo only of the fun trap, but when it comes to the many-to-many relationship, things are getting even worse. So the unified star schema looks like this. I wrote it with Bill Inman. So Bill Inman is the guy on the right, and I am the one on the left. And 929, that's good. And it was a nice adventure because I basically wrote to Bill Inman on LinkedIn, hello, Mr. Bill Inman, I know you're father of data warehousing, and I want to tell you data warehouse is cool, congratulations, but some things do not work. And he agreed with me, especially on one thing. He said, you're right, Francesco. I don't understand why there are so many data marts. There are so many copies and copies and copies and copies of the same table sales or the table of whatever other thing. So data marts, all these star schemas that are created with the Kimball methodology, they just copy the same, they start from the same table and they do slightly different. So I'm focused on shipments, I'm focused on something else. So they just repeat the same data with slightly different flavors. And I said, Mr. Inman, you are lucky because I know why it happens and I know how to avoid it. When I told him this, Bill Inman said, Francesco, please come to the United States and let's speak, let's work together. We need to write a book together. It's urgent. So I went to the US. So this is the home of Bill Inman. I was staying at his place for a week. And in that occasion, we called Steve Oberman, and he introduced me to him, and who published this book and many other books of the event of today. And we worked for a week, and this is his studio inside his home. And we were discussing a lot of topics, and then we wrote this book. So the unified star schema, let me drink a moment. In the unified star schema, all the tables are connected to a central table called the bridge. And then Bill Inman said, Francesco, because this is your invention, let's call it the Puppini bridge. And I said, but it's a funny name. And he said, doesn't matter, call it the Puppini bridge. So I still call it a bridge, but people call it the Puppini bridge. So the bridge is a union of stages. So this central table is a table that contains multiple tables that I call stages. It's a bit like the stage of a rocket. I imagine a rocket that goes to the moon, and while going up, it's releasing to the ocean some pieces of the rocket. So these are the stages containing keys and measures when needed. Potentially, all the tables of all your data marts can fit into one single star schema. And this is mind-blowing for the ones who are listening to me. Isn't it crazy? This is something that I never seen anywhere. So imagine, I've shown you earlier AdventureWorks. This is the AdventureWorks organized as a unified star schema. So here you have fact tables, you have the purchases, you have the sales, you have the warehouse, you have the production, you have multiple fact tables. So I have broken completely the paradigm of Kimball, where a star schema is centered on one fact table. I didn't like that. I wanted to give to the business users the possibility to merge together in their visualizations data that comes from multiple fact tables. Because today, the business users, if they want to see about sales and about purchases, they need to open two different dashboards of their Tableau or Power BI or Looker or whatever they have, and they have to produce the results and export them to Excel. And this is bad. It's bad. I don't want this in 2021. We can do better. Okay. So also in 2022, I don't want it. Let me be clear. So this is a star schema with a Puppini bridge in the middle and 73 tables all around. And there are facts, dimensions, and there are also tables that are neither facts nor dimensions. And there are also tables that can be seen both as facts and dimensions. So even if I still keep using this word fact and dimension, I believe that this word is obsolete. We should not anymore classify the tables as facts and dimensions, because that's limiting. It's limiting. You all have been in a project where someone said, oh, I see it as a fact. No, I see it as a dimension. No, as I see it as a factless fact. I see it a fact with the dimension. It's wrong. Classifying the tables in facts and dimensions, especially saying that the measures are in the fact tables, and especially saying that fact tables do not reduce other fact tables, they cannot connect directly. That's a big limitation of the power of the data that we all have in every database, including a silly database of tests produced by Microsoft. This same scenario happens in every existing database in the world, except there must be one database that has one fact table, but I've never found it. So how can we join together multiple facts and dimensions? Today, the dimensional modeling is the most used solution. So what is the best practice to join sales and purchases, for example, according to Kimball dimensional modeling? So I've created a second poll, and I would ask you guys, please, to go through the poll that has been there already from the beginning, and tell me what you think, because I really need your input. This is a conference of experts. I'm not telling you what is right or wrong. I'm rather learning from you. But at the same time, I'm sharing my impressions, and I'm very happy if you guys give me a feedback. So how do we do with sales and purchases? Of course, purchases and sales, they don't have each other's key. So when I purchase from a supplier, I clearly don't have the information about sales that will be in the future. And in the moment when I'm selling something that I purchased earlier, I'm not saying, okay, I'm selling you this particular unit that I bought in that row of sales. You don't do that. So sales and purchases, they have common dimensions, like the product, because we are in a business of non-manufacturing. So we are buying a mug and we are selling that same mug as it is. So the product is in common. We have the same product ID in both tables. And the time. These are two dimensions that Kimball calls correctly conform dimensions. Fair enough. So when we want to put together information that comes from sales and from purchases, what should we do according to Kimball? So one option is they should never be joined. It's forbidden to join. Another option is they can always safely be joined directly. So you take sales, purchases, you want to join by product, so you take them as they are at their original granularity and you create the join. Okay, that's one of the options. They can always safely be joined via conform dimensions. So this is a bit different because it says don't join them directly. You want to join by product, so you need to do sales, product, and purchases. So this is different from sales and purchases directly. At least this is what people say. Then one option is they can safely be joined with the distinct and inner join to avoid duplicates. And finally, they can safely be joined only when they are both aggregated with the same group by. Okay, these are the 5 options. I think that most of you have already voted, so I wanted to ask how is the voting proceeding?
Okay, let me check that for you. I think the most popular vote is on answer number 3. They can always
Okay,
be safely joined via conformed dimensions. We have
okay,
10 out of 19 votes. And the other most popular choices in second and third place are the first and the last one. They should
okay.
never be joined has 5 votes, and also the last one with the group by has 5 votes
5 votes. Okay, so
out
5
of
people are.
21.
Okay, thank you. So 5 people have answered the one of the group by. Good. So the most popular is the one that says they can always be safely joined via conform dimensions, which is exactly what I expected because this is what Kimball says. Okay, now be prepared to a bold statement. I disagree with Kimball. I disagree with Kimball. So if you join via conform dimensions without aggregating, you will break the numbers. It's simply happening. So I can show it to you with a live demo. But the thing that is amazing is that there's I speak with hundreds of developers, data experts, chief data officers, and they all say conform dimensions. Well, Kimball forgot. Again, I'm telling you my opinion. I'm no one to say the absolute truth. I tell you what I think. I think that, in my opinion, the correct answer that I think is correct is the answer number 5, the last one. They can safely be joined only when they are both aggregated with the same group by. So imagine that you have sales and purchases, and you want to see them by product or by product category, whatever, or by time dimension. Well, then in your join, you must exclude the payment type, you must exclude the supplier, you must exclude all those textual columns and dates that are not common. And also, even it's forbidden, well, you can do it, but you break the numbers. It's forbidden to aggregate them, one at product level and the other at product and date level. Even if you do this and they're both conform dimensions, but even if you do this, you are breaking the numbers because you're producing a fun trap. What is a fun trap? It's a combination of 2 tables where one contains numbers and the other is exploding those numbers. So my correct answer is you must always shrink them to the same group by, no matter if there are some gaps. We saw that, for example, in this data, product number 4 was purchased, but it was not sold. No problem, you do a full outer join. But you need to be sure that they have the same group by. Instead, if you just join via conform dimensions without aggregating, you are generating a semi-Cartesian explosion. Not a full Cartesian, but a semi-Cartesian explosion. Um, and let me tell you one more thing that I believe, that when you are joining the 2 tables directly, it is the same identical number of rows and the same identical problems that you have if you are adding the conform dimension in the middle. Try it. Try it at home. You just do sales and purchases joined by product ID, and then later you do sales, join products, join purchases. You will have the same broken numbers. It's a test that you can do, or I can do it now. We don't have much time, but yeah, we have sort of 20 minutes, so we can do it now. Even I show you the evidence that what the perception is of Kimball today is a bit different from what Kimball says, because Kimball says in the book you should never join 2 fact tables directly. However, the and you should not even join them via conform dimension. Kimball says in the book, even if you join them through conform dimensions, you need to use a business intelligence tool that is generating a technique that is called Multipass SQL, right? That's what Kimball says. But he forgets to say, be careful. First of all, different BI tools behave differently. And second, you need to tell the end user to avoid dragging and dropping those columns that would break the numbers in any case also with the BI tool. And I worked for 10 years with business objects, and for each client I was saying, guys, if you do this thing, you need to be sure that you drag and drop only the product name or product category, but don't drag the supplier, don't drag the shipment date, don't drag the no, I said shipment, I should rather say the purchase date, or don't drag the payment type. All these things are breaking your numbers. And then people are saying, yeah, but numbers are breaking because the data source is wrong or because the client is not decided what they want. No, they are breaking because you're producing a fun trap. And Kimball says, basically, Kimball says, shoot it in the BI tools and the BI tools will do the magic. True, but it's not true. The BI tools do the magic when they do the magic, but they break the numbers when you violate the rule that you should never put in your two queries, your separate two queries, you should never put those dates or dimensions that, or like, let's call them textual columns, that will generate a different group by. When you do that, you will have numbers that do not match anymore the data source. Okay, so it's time to do the live demo. So let me close the Tableau that we were using earlier, and let's have fun. I don't know if you want to let already, I don't know if there are questions, if there is something that we can discuss now, or what do you think?
There is one comment. I don't think it's really a question, but a comment from Magnus, who's saying that Kimball always repeats, "Hey, keep to the grain," and that's probably why we create so many versions of a fact table to care for your bullet number 5. So maybe you want to comment on that, Francesco?
What does exactly Kimball say? Can you see the phrase of Kimball?
Hey, keep to the grain.
Keep to the grain.
Keep to the
Yeah.
grain.
Magnus, yeah, thank you, Magnus, for this. I do not understand Kimball. I don't know this phrase. Keep, you know, the problem of the books of Kimball. First of all, they are 3, they are huge, and he's using words. And that's the thing I don't understand of Kimball, because I wrote a book and I put drawings of tables. And when Kimball says keep it to the grain, it to me, it's equivalent to say, hey, do well, do good. Tell me what it means. Because when
Maybe
I'm telling,
Magnus can clarify further,
yeah,
and we'll
please,
talk
Magnus.
about it
And
later.
it's a very difficult situation now because we are through a broadcasting and so on. Magnus, please, let's connect. I need to learn what Kimball says. I'm just saying I do not understand Kimball. Okay, so I guess it's better if we take it offline so we can have a better conversation. But my bottom line is, if that means that we should do a common group by, then I didn't understand the wording of Kimball. But my impression is that most developers are saying it's safe, and we have proven it here in this poll. Most developers are saying it is safe to join them because we have conform dimensions. So as long as I put the conform dimension in the middle, I don't care. And we have here in this call data experts, and they have answered they can always safely be joined via conform dimensions. I put always here. Well, then no. But the perception of people is that you can always do it because with a conform dimension, you are in the safe side. So, but again, yeah, it deserves a possibility of more dialogue, and I'm very happy to do it. Now, I want to move to the Tableau demo. So again, let's watch our data. This is our sales table, and it has a product called sales product, and it has a date. And this is a purchase table, which means that when the company was purchasing from the supplier, and it has a product with the same ID. So again, it's not manufacturing, it's totally buy and sell, and it has a date. Let's shoot it into Tableau, right? So I want to do a first thing, I want to do a join, because we have seen that you can do join and in-memory association, but let's do a join for a moment. So I take sales, and I don't join it directly to purchases because it's no, let's not do that. Let's put the product in the middle. I want to see sales and products, and I want to join them by the product ID, sales product, and the product ID. And then I want to take purchases. Okay, so here is already a first thing. Because I want to achieve a self-service business intelligence, this is a bit difficult for a business user because it's there are multiple combinations. It could be like this, could be like this. Plus, this is not a join. So I want to clarify that we should not use this. We should use the one that is similar to SQL. So I double click into sales and I put products. Okay, and I put sales product and product ID. And then I want to join. It's all inner join. No worries. It's everything referenced, so don't worry about that. And then I put purchases. Okay, so first of all, yeah, it does not give me the graphical possibility to put it here. So this is already a bit weird. So probably the correct thing to do to be properly Kimball compliant is to start our query from the products themselves, which is again a bit against my philosophy. But let's start from the beginning, and we start with products, and then we do sales. Sorry, I'm doing wrong thing. I want to do it as a join. So I enter inside products and I do sales, and I do product ID and sales product. Okay, and then I double click on purchases, and this time it's putting it there, and it's because it's all denormalized. So it basically the between these two it's referenced, so it's fine. Well, sort of. We will see. Well, actually, probably should do a left join here. These are all things that a business user cannot do. And let's put a left here. This way we are doing a bit better. If we do a full outer join here, it could break everything. Again, a business user doesn't know that. Let's do it this way. But I guarantee whichever flavor we do, we are going to have duplicates. So now we have produced a table, and we are going to see the result. So I go to products, and I put the product ID, no, the product name, sorry, where is that? It's here. And then I put the sales amount. It's sales amount, it's here, and the purchase amount. You see, this is already a problem. It's not working. So I should probably put inner joins, and then we are starting all this blind navigation. If someone has an advice, I'm exploring a domain, which I never do because I already know in advance that it's not working. So let's do inner joins. People tend to do this. Okay. Now let's see what's happening. Nothing is happening. The problem is, imagine that you are a business user and you just want to see the sales amount. You see, Tableau broke. It's a thing I never do because Tableau is breaking. So the way, basically, if you look at these two tables, there's no way that you will be able to produce a denormalized table that doesn't create duplicates, unless you do a union, and that's what I would recommend. But again, for business users, doing a union is difficult. They don't know even what a union means. I want to show you also the other problems that you have with Tableau today. Again, I start by this data source, and then I will quickly show you the unified Star schema. We don't have much time. So if I do sales and then purchases, no, let's do products first. Sorry, I'm trying to read the mind of what people would like to do. We could do hours working on this.
Well,
So
we only have a few minutes left, Francesco,
exactly,
so we need to wrap up in 2 or 3 minutes.
sure. So if you now do this join, product ID and sales product, and then you do sales and purchases, and then again you do sales product, and I already know that it will not work, and purchase product, and I go to visualize, I want to see my numbers, so I put product name, and then I put the purchase amount and the sales amount, and then I put the totals. So the totals now are actually giving the correct totals because we are in memory, but there is here a purchase that has no product, and it's impossible. All these combinations are basically killing the business. So now I have just 1 minute to show you the unified star schema and to show you how everything becomes simple. I go now to Excel and I open a data source that is organized as a unified star schema. I always start with the bridge, Puppini bridge at the beginning. And then I say, okay, I take the sales, I double click and I lift my hands. I don't need to do anything. And then I double click on purchases, or let's say products, and I lift my hands. I don't need to do anything. And then product sales, so let's do purchases. I lift my hands. I don't have to do anything. All the joins are automatically correct because there is a naming convention. Then I go to do the visualization, and now I can do all the combinations. So I can look at the, for example, the product name, and then the sales amount and the purchase amount. So the purchase amount, sorry, it's here, purchase amount. Actually, I should put this sales amount. That would be a long story to explain you the difference. Okay. This was shipment amount. Okay. So now these are correct numbers. So they are reflecting the truth. They are all allocated to a product and the totals are okay. And now, very final thing. If I want to change now this report and see it not by product, but I want to see it by time, then I just go to my data source and I'm saying, okay, no problem. I add the calendar, double click, I lift my hands. I don't need to create joins. They are created automatically. Okay, so that's created. So now I go here and instead of the product, I can put now, I go to the calendar and I can put the year month, for example. It's already changing the point of view, which normally is impossible to do with the same organization of aggregations, with the same data model. So instead, with the unified star schema, you can explore multiple fact tables and through the multiple shared dimensions, and you never have problems. So I can do it by weekday, I can do it by date. So I put the date here and then I drill into the date. So it says that there are, I can break by quarter and by month and by day. And I'm seeing all the history of the sales and purchases and distributed in time with the same query. This is all extract. So the data is inside Tableau. I could disconnect from internet and this is already inside Tableau. And I'm able to bring into the report the granularity of all the fact tables, the full granularity, because I can put the sales ID, the sales data, whatever I want. And I can also add now to the same analysis also the shipments. So I go here. If I want the shipments, what I do, I double click. I don't do anything because it's joined automatically by the naming convention. I wait. When it's done, it's done. And I go here and I say, okay, now I want to watch what it was happening across time, not only with purchases and sales, but I also want to see the shipment amount. So I double click on the shipment amount and I see that initially there was some shipment and then there was a purchase on the 2nd of February and immediately a shipment of 100 on the 3rd of February. This cross-fact analysis of multiple fact tables with multiple shared dimensions, where I have in one report all the possible combinations of the subsets of the dimensions and everything, in my opinion, is today something that no business intelligence solution is doing. This is called Unified Star Schema, and I have done it in Tableau. I've done it, and I'm finishing now. I've done it with ClickView, with ClickSense, with Power BI, with Spotfire, with SiteSense, because it's a generalization, it's an extension of the Kimball approach, and whatever can be done in Kimball can also be done by the Unified Star Schema. These
We
are the
need to wrap it
factors,
up here, really, Francesco. I'm sorry to
and
interrupt,
that's finished. No,
but
no,
you're
no, that's,
at the end of the session, so that's
yeah.
great. So
Okay, so
there's
that's
quite a few interactions in the chat. So Francesco, if maybe after the session you can have a look in the chat and check out whatever is happening there, that would be great. But I think for now we really need to wrap it up because we've run out of time. So thanks a lot, and
thank you. Bye bye.